Hi, I'm Bill Lancaster, and I'm going to be your host for this video on calculating the number of flutes you can fit onto your bow. I had a previous video on using this Paul Howard fluting jig, which is a wonderful thing. I'll show you right over here. It's a Paul Howard fluting jig. Now we just need to calculate, if we have a bow, how many flutes we can put in it. This has 60 flutes in it. And you can do that with this wonderful indexing system. So this is 60, this series of holes, 48, 36, or 14 flutes. And you can adjust the number of, or the setting by using this handy system, which, there it is right there. So you just tighten that screw down, and that's the next notch. So I can do 60, 48, 36, or 14. How many can I get on this bow? I've got this big bow. This happens to have 60 on it. But I need to, before I cut these, I need to know how many I can fit on there. The indexing system will cause it to all come out even. You don't end up with half of a flute at the end, because this is what this indexing system does. It makes it come out even all the way around and at the end. But how many of these flutes, or in this case reeds, can I put in this bow? That's the question. So I hope I can get 60, and that's what I'm going to try to do. But what I'll do is go back to the algebra that we learned in school, try to brush up on it, and I confess I had to actually look up the formula on the internet to make sure I had the right one. But we're going to measure the circumference, measure the diameter rather. The circumference equals the diameter times pi. So we're going to measure that diameter, not here at the top, but where these flutes are going to stop. I'm going to use this nice figure-8 caliper just because it's easy to get wide open. And so I'm going to measure at that point the diameter of the bow. And I get that diameter by going to a ruler like I have here. Put it on the ruler, and we're going to get that diameter in millimeters. It's just a lot easier to work with, and this is an English system, this Paul Howard system. It's already done in the metric system. So when I do that, I get 21 centimeters, or 210 millimeters. Then I just do the little formula. Circumference equals pi times d, pi times diameter, pi in this case times 210, and pi is 3.1416. So I take my handy calculator, which is on my phone, and do this little calculation. So I want to have C equals pi d. That means 210 times 3.1416 equals 659.7, call that 660. So I'm going to take 660, and that's going to be my circumference. Now, how many of these flutes can I get in that 660 millimeters? I'll take the width of my router bit in millimeters. It happens to be a 3/8 of an inch bit. I've already done a little conversion on that. So the 3/8 of an inch equals 9.5 millimeters. You know that 2.54 centimeters per inch, that's 25.4 millimeters per inch. So you can kind of do that little calculation and find out how much this is. So I've got 9.5 millimeters of width of the router bit. I need to divide that into the circumference to find out how many of these flutes I can get on there. And so when I do that little calculation, I take 661 divided by 9.5, and I get 69.4. So I've got 69.4 spaces. That means I can get 60 flutes on this thing quite easily, and I'll have a little space between each one of them. You see this little flat spot? That's the space between each one at the top. So if I use the full 3/8 of an inch router bit, I'll have a little bit of space left because I have room for 69.4 flutes. I'm only going to put 60 on there. They're going to overlap a little bit at the bottom. That's okay. This overlapping actually makes them taper slightly because they overlap one to the other, and that makes them taper as you go up. They don't taper at the top. That's the full 3/8 of an inch width up there. So I can easily have my 60 flutes, and I'm going to put those 60 flutes on there, and I just have to do it by using this indexing system to get them, and have a little bit of space between them. Now, if the number comes out below 60, what do I do about it? There are 4 options. I can go to a smaller router bit. I've got a 3/8. I can go down to a smaller diameter. I can withdraw the tip of the bit a little bit so that I'm using less of the bit, and that will actually, if this is a round over bit, I use less of the width of it, and that will make a narrower flute, and I can get more of them on there. I can move the end point of my flute lower, which will make the circumference smaller. But if I do that, I'm going to kind of mess up my artistic design, so I'm hesitant to move the circumference to a smaller diameter. But I could do that to make it work. And the last thing is just to overlap the flutes all the way up to the top. If you overlap them, you'll see you'll have this little, in this case, it's a little ridge. It would go all the way to the top. I would not have that little flat space. I would just do away with it. Instead, I would have a little ridge all the way to the top. That's okay, you know. As long as you don't overlap it too far, you'll be all right. So those are the ways you can go about doing that. If you want to have 48 flutes instead of the 60, you're just going to have more space between them. I can go to a larger router bit, like a 1/2 inch, and make a wider flute, or just have more space. It's up to you to how you want to design that. It's I can go to a larger bit if I want to use a 48 flutes, or just have more space between them. So that's about it. It's simple to kind of calculate. Just remember that formula. Circumference equals pi d, pi times diameter, and that will give you the circumference. And divide that by the width of the router bit in millimeters, and that will give you the number of spaces you've got for cutting flutes. And if you have a little bit more than 60, when you do that division, you'll have a little space between them. If you have less than 60, you need to make some kind of an adjustment, or just let them overlap one. That's about it. So, hope you have some great experiences with this Paul Howard fluting jig. I just like mine very much. I've got some good results, as you can see, with it. So, happy turning. Bye.